This is a real quick hit of a video that moves you from air masses to fronts. And a front is simply a zone where two different air masses meet. And the air masses are different in their density. In other words, there's one cold air mass and there's one warm air mass. The warm air mass is less dense, so it's more buoyant, usually rides up. And the cold air mass is more dense, so it sinks, usually rides down. In looking at these two, the easiest way to get into this whole field is to talk about stationary fronts, because they don't go anywhere. They're stationary for weeks sometimes, so they're very easy to observe. And when we look at stationary fronts, that is two different air masses, a warm air mass and a cool air mass next to each other. Generally, if we had the south down here, the warm air mass would be heading north. And if we had the north up here, the cool air mass or the cold air mass would be heading south. But they go past each other and neither one is stronger than the next one. So they ride next to each other and move alongside very, very slowly to the point where they hang out and they may not move for weeks. In this case, the way they're noted on maps is the cool side has a direction that it would like to go in, and that's noted by the tip of the triangle, the blue triangle, blue, cold. And a cold air mass is more forceful and more dense than a warm air mass, so it has a spiky triangle. It's going to pierce the veil and get through. The warm air mass is generally going in the opposite direction. This one wants to trend west, and it is red because it's warmer, and it has circles because it's not nearly as aggressive as the cold air mass could be. The reason it's not as aggressive, it just likes to ride high. So that's how you will see them on a surface map. I talked about the fact that they don't move very much. There's not a lot of winds because winds would move them. So there's very light winds around a stationary front. That could be a source of wind shear. Remember, wind shear has different speed and different direction. This doesn't have much in the way of speed, but it does have opposing directions. So we talked about directional shear. Stationary fronts can be a source of wind shear and directional shear alone. And because they can stay in place for long periods of time and generate some rain, they can generate flooding by the fact that they just don't move and they continue to rain in moderate amounts. This is an idea for you. Here is a surface map. Here is the stationary line. You have cold front direction, warm front direction, cold front direction, warm front direction. Nothing's moving, right? And so it's just hanging there with opposing forces. And these are very well known coming out of the maritime tropical air masses that are warm. And you have continental polar air masses coming down that are cold. Flash flood warnings are associated with stationary fronts. And that's when you hear about driving conditions and flash flood warnings. I know I'm an EMT. I get pulled into rescues all the time. When you hear about drownings in flash floods, they're generally drownings from people who drove too far into a wet surface. So please be very careful when you hear a flash flood warning, especially during hurricane season. That should be it for stationary fronts. On to cold fronts, the exciting stuff. And I should let you know, there is a great video on Blackboard of a cold front. It's just the best. So I hope you will watch it because it's like a freight train moving into Tucson, Arizona. And it's really entertaining. I hope that you will watch it and be amazed. Talk to you soon.